Hello, everybody, and welcome to another Cloud Native Data Management Day session. Today, we're going to be talking about securing your stateful workloads with encryption, audit, authentication, authorization, and ownership. My name is Ryan Wallner, and this is the co-located event at KubeCon in October 2021. I'm a manager for the technical marketing team here within the Cloud Native Business Unit, the Portworx Business Unit here at Pure. And to help me kick off the presentation, I'm joined by Bhavin Shah. Do you want to introduce yourself?
Yeah, hello everyone. I'm Bhavin Shah. I'm a technical marketing manager in Ryan's team, and we are glad to have you watch this session with us. So let's start by talking about Portworx. Obviously, Ryan will deep dive into security and everything that we just spoke about in just the title. But when it comes to Kubernetes storage or Kubernetes data services, Portworx provides an end-to-end platform that not only deals with security, so RBAC and authorization and authentication, and encryption and audit, but we also have additional modules inside the Portworx platform that help you with things like PxStore. PxStore provides that storage layer or Kubernetes storage layer for your pods. PxMigrate, which enables you to migrate your applications running on one Kubernetes cluster on-prem or in one public cloud to a completely different flavor of Kubernetes. So you can be moving from Tanzu to an EKS cluster in a different cloud environment. We have PixiCuddle, which is the focus for this presentation, but additional modules also include PxDR and PxBackup to build disaster recovery and data protection solutions for your applications running on Kubernetes clusters across any cloud provider. And then PX Autopilot that helps you automate storage capacity management. So you can, as an administrator, you can set up autopilot rules that monitor, that work with the monitoring source and allow you to set actions that can be taken when specific conditions are met. But without further ado, let's move on to PX Secure or PX Security. So as part of the Portworx platform, PX Security provides encryption and access control for your applications at the storage layer. So this includes cluster-wide encryption. So any data that's being written to the Portworx storage layer is encrypted, and you can bring your own keys if you want to. So BYOK. We integrate with major key providers like HashiCorp Vault. If you're using the native key management providers in Amazon or Google, we integrate with those as well. So depending on your preference, you can bring your own key to use with your Kubernetes cluster and Portworx. We also provide encryption at both the cluster level or the storage class level. So as an administrator, you can decide how and when you want to encrypt your persistent volumes. We also provide role-based access control. So this not just includes authentication, so making sure that the user who is trying to access resources inside your Kubernetes cluster is authenticated. But then we also talk about authorization to make sure that user who's trying to access the resource has the correct permissions or privilege needed to access that specific resource. And then we can integrate with LDAP or Active Directory resources. And then one additional thing that we wanted to highlight was PxSecure also gives you the ability to audit access. So you can, as an administrator, you can go back and look at which users have tried to access specific resources in your Kubernetes cluster. Next, let me send it over to Ryan to talk about PxSecure in more detail. Over to you, Ryan.
Thanks, Bhavin. So the first thing that I want to double click on is encryption. So Portworx uses the de-encrypt device mapper target for encryption of the actual Portworx volume or the block device that it presents to pods and containers within Kubernetes. So encryption actually happens at the Linux kernel using de-encrypt module with the hardware acceleration on the Intel CPUs and things like that. No data is really ever interpreted by the device mapper target. So the flow of the data from your containerized application to the local device is really sort of depicted as you see above. Portworx provides both etc4 or XFS file systems capabilities that can be bind mounted into the container, and the underlying block device is presented with that file system using the LUX created by dencrypt. So you'll see that the dev mapper path is actually presented to your container in this case, rather than if you weren't using encryption at the device level. If you weren't using encryption, you'd see something like dev pxd, but in this case, you'll have that dev mapper presentation for that as well. Portworx also never sees unencrypted data. In this case, data stays encrypted at rest and over the wire. So backups of your volumes are also encrypted. So a great way to really, hone in on the integrity of what's in there. Portworx uses the libgcrypt library to interface with the encrypt kernel module, and so it uses AES 256 cipher as well in this case. So you're very well protected, and the passphrase is actually something that you provision or configure at the application or control plane level. So if you're a Kubernetes admin or a user with the capability to provide your own passphrase, this is where it's passed down to dencrypt to do those volume attach operations to be allowed to do that. And that passphrase is actually held in the external key management system. So something like Vault or AWS KMS, this is where Bhavin was talking about sort of the bring your own key capabilities. Now, you can use the built-in Kubernetes secrets, and that totally is fine. But just keep in mind, there are external systems as well, which you can manage those passphrases and instruct Portworx to use them. Now, on that topic, those KMS systems, like I mentioned, HashiCorp, Vault, IBM Key Protect, or AWS KMS, and some others, Portworx needs to be instructed to use them. So Portworx authenticates with these external KMS systems provided by the administrative user of Portworx itself, and creates and a user or an admin on behalf of the user creates that key pair with the KMS system. Portworx also stores the public key information in the key value database, and then retrieves that when it's needed for accessing the encrypted volume. So the user provides that identifier, the key, and Portworx fetches that public key securely, of course, and invokes the APIs to fetch that data key, and then uses it in the process for encryption that we saw in the previous slide. So keep in mind, definitely take advantage of using those external KMS systems for your data security component. Often they have other uses than just volume encryption passphrases anyway, so you might already have one. The other topic that I want to double click on is the component around self-service and trust. So many enterprises have security policies when it comes to controlling how users actually set up authentication and their credentials, and what access they have, how much privilege they have. And so these controls are often determined by the group that belongs to, which role they're in, right? So in an organization, they may belong to a group or a role. And so this is often implemented using, Active Directory or LDAP within an organization. So Portworx does, contain the ability to provide this type of integration with what enterprises already use, and keep adding to their portfolio as they always would. So these cloud native applications are no exception when it comes to having the need for a subset of controls that exist within Kubernetes. Now, in Kubernetes, there are role-based access controls, and that's at the cluster level, but there's really no RBAC that extends into the data management or data level. And so there's no way to really authorize or authenticate access to data itself, meaning if you got through the initial cluster security and it could access the data components, how do you authorize and authenticate there? By adding, these types of features natively in the data layer for containers, Portworx can actually provide this self-service and trust component that organizations already use at the cluster level. There are a couple different types of integrations that Portworx uses to do this. There's by default a self-generated token that can be used based on the information of a user and what group they're in. And then there's the OpenID Connect OIDC integration. So OIDC is a sort of the standard model for authenticating users, and it's a great solution to integrate with other systems like Active Directory and LDAP. If you're familiar with Keycloak or Okta, these are some popular ones out there today, and they can kind of consume your LDAP or AD information and then provide it to Portworx as well. The self-generated token model, it's really more or less a self-contained method where administrators can actually act as the token authentication or a token authenticator. Using command line tools. Actually, Portworx provides one with their CLI, as well as just generating them with a custom application. But that is absolutely an option for self-generated components. Portworx needs some basic information, whether using OIDC or self-generation. For a token to be valid, it must use either a shared secret within the Portworx and Kubernetes system, a private key, or of some sort. And so Portworx needs to validate these tokens using either the public key or the shared secret in any case. So Portworx actually comes with a few different roles within its own role-based access control system by default. The ones listed that you see here are the system admin, system view, and system user. The admin can run any command, so pretty much as it seems. The view is really a read-only method, and the user can only access the lifecycle, meaning create and clone and things like that. There is a fourth one not listed on this slide, which is guest, and it's similar to system.user, but it's only used for public volumes. And the reason this one exists is because if you were to take your PX security enabled Kubernetes cluster and it wasn't necessarily enabled originally, you may have a bunch of our already existing volumes and things like that. And so you want to ease into the process of introducing security to your end users. The guest role can be enabled, and basically volumes become public until they start using the security role. And that's sort of the way you can introduce it into your organization as well. So PixiCuddle, gives you some, which is the CLI, gives you some more fine-grained control over users and what they can do, but often isn't the way to isn't the way users interact, right? Users in Kubernetes interact at the PVC object level or the application such as deployment level, and they don't really, interact with the data system at all. But if you had different roles for administrators of your data management system, you may have an admin or a user within that context, and those can be created from PixiCuddle as well. And lastly, the ownership model within this control here is really the model composed of a user where it can list groups and collaborators to access the resource. So if you had a volume that a user one could own, right, and they created the volume, they could actually give read access to group one, which means that only user one can mount the volume, but group one who has read access to the volume can clone that volume and actually use that volume as well. So that's sort of a collaboration, in sort of the data science way that you could actually integrate security into those workflows, make sure that they're, the owner of that that data and that volume can share before it can be cloned and used again. And on top of everything, security is great, but it's hard to really understand what's going on unless you have some sort of audit capability. So PixiCuddle does have a audit security component. There are access, and then there's the audit capability, and those are within a couple different logs. And in the demo, we'll show you how you can actually scrape those and present them in something like Kibana, Elasticsearch. So that's really an overview of the different components within PixiCuddle. And I'm going to jump into a demo at this time. So let's get started. So here we have a Openshift dashboard here, and we can see that Portworx is enabled, and we do have security enabled here. So really it's as simple as adding the enabled equals true component to your storage cluster integration. And all the documentation is in fact listed on how to do this within Openshift. It can obviously be enabled without the operator as well. There's a few more steps, but the operator makes it very easy. So now we can actually jump into the Portworx container here and look at the guest role. We talked about the guest role before. It's enabled by default, but in this case, we've changed it to say, give them the ability to use everything, but don't let them create resources. So they can't create volumes or backups or migrations. And this is really just the ability to customize what guests or public users can do. Now you can absolutely disable it if you want, and that may be the better case if you start off with a very secure way of doing things. And so now we can drop into the PixiCuddle CLI and see that there's a bunch of different contexts, and these can be actually integrated with LDAP. I've created them sort of locally and use the contexts in this fashion. So there's an admin, there's a user, there's a read-only, and we can actually see what that profile would look like. So, if you're using OIDC or if you're using like Okta or Keycloak, this information may be imported, but, we're doing the self-signed and self-generated. So we've defined it here, both the user as a view and a user as a read-only user. And so we can actually set these contexts within PixiCuddle here. And as an admin, I would, authenticate with this, and I can pretty much list everyone's volumes and have admin capabilities. But if I were to set a view user from the context of PixiCuddle, I could only do so many things. So in this case, if I tried to create a volume from PixiCuddle, I don't have admin access. So again, you probably don't have or won't have many users interacting with Portworx at the PixiCuddle level. It'll be more or less from the Kubernetes level, but think about bad actors trying to get into a system. If they get into a Portworx node and still try to do some things, they still have to provide that token as well. So if you were to create a PVC in a PX secured Kubernetes cluster, this is what it would look like, right? So you have just a normal PVC and a PVC PX replicated storage class, which doesn't look strange and pretty much is the way you'd expect things to work. However, it's pending. And if you look at the events, you can see that the access has been denied because no token has been able to be used and authenticate the user. This is basically just saying, hey, you can't create a volume in this Kubernetes system without providing me a token which I can validate. And Portworx needs to validate that token before letting you actually manipulate resources, such as create volumes. And so that's what's happening here. Now, admins will need to provide in most cases, provide the storage classes which have access to these tokens, meaning as a user, you can create a secret with a token, but an admin needs to really, in most cases, set up that shared resource as a storage class. And so here we have a storage class that's saying encryption is on, and use the user token, which allows all users of this Kubernetes cluster to authenticate with Portworx. In this case, the admin would be responsible for rotating that and everything and keeping it secure. But this is the case where you would have a single Kubernetes cluster, maybe to one team, and that one team can all use the same token, right? It's not multi-tenant in this way. So we've created a volume with this storage class, and it's up. It's not being used by an application, so it's detached, but we were able to create that resource. Now we can actually dive in and look at a multi-tenant way of doing things. So say we have two different teams using the same cluster, an analytics team and a DB ops team. Well, they're both part of a user group, but they have access to different projects within, or namespaces within Kubernetes itself. So I can log in using the OC command. I can log in to the console, and I only have limited access as a DB ops user, meaning that if I headed over to the project view and looked at the pods and things like that within the DB ops namespace, I can see there's a bunch of pods running. I have DV2 running here, and I'm able to interact with these resources. Note that, in Openshift itself, there's role-based access controls which limit this user from having access to other namespaces, right? So within that DB ops namespace, I have my token to my tenant. And in this case, I have storage classes made for DB2 that specifically target that DB ops authentication mechanism, meaning that if I tried to use a different token from a different namespace, I couldn't do that as a DB ops user, meaning there's Openshift role-based access controls, which limit me from consuming that. And then there's Portworx role-based access controls, which limit, authenticate me as a DB ops user. So what we can actually dive into here is we can see that I have a data volume, which is a PVC created from that from that storage class that's using the multi-tenant security model. And if I were to use the Pixie utility, which is an add-on to KubeCuddle, I can actually take this volume and look at who owns this volume, right? So in this case, DB ops is that ownership, meaning that the DB ops user within the Portworx ownership model is the only one who owns that model and must allow you to collaborate with it. So if I tried to pass in an analytics token and inspect it, look at it, do anything with it, clone it, I get an access denied. If I tried to delete it, I get an access denied. And this is using my analytics token. So as a Portworx user, I'm a valid user, but I have a token that doesn't allow me to interact with certain resources. So this gives me the ability to sort of drive Openshift or Kubernetes in a multi-tenant secure way, obviously with encryption, but also with role-based access controls at the volume level. The other thing we can do here is look at a full example of a volume within a Postgres deployment. And we've provided a Postgres deployment here. We can go ahead and create that Postgres deployment. And that volume itself is going to be encrypted using the encryption mechanisms we talked about earlier. So one way that we can verify this, we can see Postgres is going to be up and running shortly. and that uses the secure REPL3 auth. So it's using the authentication plus the encryption. So here we can see our Postgres pod and our Postgres data volume here. We can click on our PVC and get the storage class name and verify that we are in fact using that secure storage class. And if we head over to our CLI, we can actually dive in and use the PixiCuddle utility once again to see whether that volume is in fact encrypted. And here we can see the dev mapper, CoreOS Lux root information and PixiCuddle. ENC means encrypted device. So we are in fact getting an encrypted device presented to our Postgres volume. If we dive into one of our Portworx nodes here, we can see that Portworx is running on this particular Kubernetes node. We can use the terminal here and use the ocdebug command to actually get access to our host in this case. And what we're going to show is how you would then go about auditing the information here. So as we mentioned in the host system, you can get the open storage audit log. So this is everything that's happening from a security audit perspective. Whether it's the Kubernetes system operator trying to do something in the system, or if it's the a specific user. And we can offload this by basically running filebeat, capturing the information from those logs. So we have a filebeat config here that's targeting both of those paths, and we'll send it off to Elasticsearch so that we can present it in a way that provides us some more information based on the audit prefix. So that will be an Elasticsearch with the audit prefix, and we can consume it through things like Kibana dashboards. So here we have a Kibana dashboard, which targets those audit logs that we can see here, providing information from our security-enabled cluster. We get some access information, such as we get access denied for guest. This is expected because we denied guests access to do certain things. And we can sort of force some components to start to create some audit capabilities. So I'm creating some users that aren't real and trying to force create some volumes, and we can get access denied to the volumes. And what you can see here is that on the audit log here, we see those access denied to that specific volume by that specific user. And so we can sort of use these dashboards and these audit logs as sort of a way to say, well, hey, someone's really trying to do something they're not supposed to this specific volume. We can dive in and get more information about who and what user is trying to do that, and take necessary action based on the audit information that we have in here. And so pretty useful to utilize those audit capabilities within your Kubernetes cluster for your PX-enabled cluster. That's the demo, right? So we really covered, how does encryption look within a storage class, how role-based access control is used as both a single tenant or a multi-tenant, what ownership looks like, and how audit actually presents itself. So that is all for this demo in Cloud Native Data Management Day. And until next time, take care.